Well, I hope you enjoyed your little break, and I hope from the first part of this video you can see how our model works in a parallel circuit. I hope you know how a parallel circuit is connected and understand what the rules are for calculating current in a parallel circuit. Now we're going to look at voltage in parallel. So if you remember, we've got to now look at voltage. And remember that voltage was to do with the energy or the number of Mars bars per lorry. So Mars bars per lorry equals our voltage equivalent. And remember, it is the store manager, the Mars bar factory manager. She was the one that set the Mars bars. So I think this time we're going to go for 20. So she's going to decide that every lorry is going to get 20 Mars bars. So again, if we look here at the start, then this lorry has just been through the factory, so this has to have 20. When it arrives back at the factory, it must have 0. So remember, potential difference is the difference between the number of Mars bars at one side and the other of the component. So here it's going to gain 20 Mars bars. So we're going to take this lorry, remember, and we're going to take it along to Tesco. That's going to go along to Tesco, and think about where it's going to go after that. Well, when it goes from Tesco, it's going to go back over the bridge and it gets back to the Mars bar factory. So this seems a bit strange, but for each lorry going to Tesco, it has to have 20 here. It must have none here because it's no more deliveries. So it must deliver 20 boxes to Tesco. And there's the lorry going back over the bridge, 0 there, and then it gets filled up. Let's have a look at another lorry. This lorry down here, it's going to go to Aldi. Well, we know it's got 20 boxes here. It's got 20 boxes here because it's not made any deliveries. If it delivers to Aldi, well, it's only going to make a delivery to Aldi. Can't go to Sandu stores, has to go this way and over the bridge. So therefore, again, it must have none here. So it's got 20 here. It's got 0 boxes here. So it must have delivered 20 to Aldi. How strange. What about the lorries that go to Sandu stores? Well, the lorry that goes to Sandu stores must have 20 here because it's not made a delivery. It must have no boxes here because it's on its way back over the bridge to get filled up. So again, it must have delivered 20 boxes. So I think that's not what you expect maybe, but what we found is that the voltage across each branch is equal to the supply voltage. In other words, if you're a lorry, you're going to deliver all of your energy, all of your boxes of Mars bars to the one store that you're going to. So in this parallel model, one electron only goes to one component in each route. So let's see if this works. So I must make sure I connect it to the right side. So here's my voltage across the cell. So that's like my Mars bar factory. That's giving me a voltage of 9 volts. So what would you expect across each lamp? Well, let's try it. And I'm hoping that you'll predict that this one is 9 volts. This lamp, 9 volts. This lamp should be 9 volts. So the voltage across each branch is equal to the total voltage across the cell. We can click it across there as well. That would be 9 volts. There to there, that would be 9 volts. So I hope you're really pleased that you now understand or can work out the current and voltage in series and parallel circuits. Because next lesson is time for a practice. So here we've got a real setup. So these numbers are what you actually get. It's very difficult to see. The one on the right is the measuring the voltage across the two cells. That's given us a total of 2.487 volts. And if we can look across each bulb, we have 2.443, 2.446 volts, 2.434 volts. Now I know for you, you think, well, that's not exactly the same. And my argument would be that there are some pretty poor connections. So the wires And if we're thinking about that in terms of our model to try and explain it, what we'd say is like some of the lorry drivers are really having trouble getting through the snow and getting through traffic jams on their route, so they're probably going to nibble a few Mars bars on the way. I also had to bypass the switch, because if I put the connections across the switch, push the button, these numbers weren't very good because there's a really high resistance across that switch,